Every road I take, every trail I track, leads me back to the relationship I cannot escape. A marriage of convenience, implored the impala. The impala is a 40 to 70 kilogram medium-sized antelope that lives in southern and eastern Africa, where ticks are a major problem in the environment. Over generations, the impala developed a mutualistic relationship with oxpeckers, small passerine birds that remove ectoparasites such as ticks from larger mammals and feed on ungulate wounds of mammals. According to PhD biologist Tiffany B. Plantain, this type of interaction is known as an interspecific interaction, meaning it is an exchange between two species. In this mutualistic relationship, each of the species benefit by sharing a common action. However, to be honest, this relationship is not the perfect one, since there is some cheating that may occur. Today, we will talk about the benefits of the symbiotic relationship as well as some of its negative aspects, with a focus on the evolutionary mechanism underlying this interaction. Listen in for more about convergence, evolution, co-evolution, adaptation, and fitness in today's talk.
Just as competition between city-states in Italy produced the Renaissance, so did competition between various organisms produce the valuable method of mutualism. And if you're not a history buff, what I mean is that competition helped drive adaptive change by forcing competitors to improve, adapt, and overcome. In the words of Egbert Giles Lay Jr., competition favors innovation, exploiting new resources or opportunities, or using old ones better. Basically, the first thing nature did right was pit every organism against each other. Disclaimer: this theory of mutualism is economic in nature and uses the observations of human interactions to conceptualize the mechanisms by which mutualism might have evolved. There are two different types of mutualism, which include mutualism with division of labor and without division of labor. I'll explain the latter first. Mutualism without division of labor is a relationship in which each participant benefits him or herself by pooling his or her effort, and no one participant is directly affected by the efforts of another. One condition for mutualism without division of labor is when there is no possibility of cheating. To put it simply, imagine a partner project, and you are randomly assigned a partner. However, while you must cooperate on this project, each of you receives an individual grade based on your own contribution. On the other hand, the more common type of mutualism with division of labor occurs when two species must pool efforts to get in return. In this case, the trading of effort or labor is only favored when the benefits outweigh the costs on both sides. Otherwise, one party will begin to cheat and take more than their share, making the relationship unsustainable. Going back to that group project analogy, now imagine that you get to choose who your groupmates are and that the group grade is shared. The goal is now a little different. Instead of cooperating to finish the project, the more immediate danger is the infamous class hitchhiker. In other words, the more important goal in this scenario is to make sure everybody does their fair share. The first of nature's remedies is long-term mutualisms. These are usually transmitted vertically from parent to offspring and obligate, where, quite literally, one cannot live without the other. To analogize this, let's say you have a partner you've been working with your entire life, from stacking building blocks to your recent AP biology lab. Oh, and this has also been true between your parents, your grandparents, your great-grandparents, all the way up ever since your ancestors first attended school. The catch is, if one of you tries to get away with slacking on any single collaboration, both of your grades drop and never stop falling. Also, your offspring will never even make it to school. One example includes the theory of endosymbiosis, where the mitochondria cannot live without its host cell, and if anything were to go wrong, it never goes right again. The others are horizontally transmitted symbionts, where the mutualistic interaction is not passed down generations. There are three constraints. The first is called partner fidelity, meaning injuring the partner also means directly injuring oneself. It's kind of like tattling on your partner for not doing their share of the work, but then also getting exposed for not doing anything yourself. The second is called partner choice, where the mutualism overcomes any opportunities to switch partners, making partnership almost entirely exclusive. Most group projects don't have this problem because by the time you wish you had a different partner, it's probably 3 days past the deadline and it's your fault for not reporting sooner. Finally, the third is called partner sanctions, where non-performing symbionts are punished to preserve a healthy mutualistic relationship. I think this one speaks for itself. In terms of the oxpecker and the impala, oxpeckers are a horizontally transmitted symbiont, as in it doesn't get passed down impala generations. Partner fidelity and partner sanctions are characteristic of this relationship because an oxpecker depends on impalas to feed, and impalas need oxpeckers to clean ectoparasites from the body, meaning one would starve and the other would lose energy efficiency without this interaction. In terms of partner sanctions, cheating oxpeckers that feed on the wounds of impalas instead of ectoparasites are more frequently removed by impalas and therefore forced to find other means of consuming. Unfortunately, oxpeckers are not exclusively faithful to impalas, as they feed on a variety of other grazing mammals like cattle, zebras, sheep, goats, and giraffes.
Adapting to an environment is an essential factor in helping one to maintain fitness. The host species, in this case, the impala, tolerates the oxpeckers that feed on ticks rather than the wounds, so the chances of tick infections and the healing time for wounds decrease. According to a study done by Dean and McDonald in 1981, tick feeding is generally regarded as beneficial to the ungulate host, whereas wound feeding can be detrimental as it prolongs the healing time of wounds and increases the chance of infections. If you think about it, let's say someone were to give you your favorite home-cooked meal and another person gave you a distasteful food. Which would you cling on to and why? The obvious answer would be the person that provides the delicious food, and just like this, the host accepts the action of the oxpecker only when it is advantageous to his or her fitness. Oxpeckers also like to feed more on ticks than they do on wounds because it ensures that they have a host and a place to get their nutrition from. The oxpeckers are attracted to the larger animals, which means those animals have more help in removing parasites. Impalas also adapt to the decreased help by oral self-grooming, which helps them remove ticks and prevent infections. This is a greater competition for food amongst the impalas for oxpeckers, so they adapted by forming a mutualistic relationship with the other animals to maintain a food source. The need to overcome similar problems leads to the development of similar traits. In this case, zebras, giraffes, and other species mentioned are not closely related to impalas phylogenetically. However, they do show signs of similar adaptations to the oxpeckers. These species tolerate the oxpeckers in order to remove the tick load, which can decrease their risk of infection, a direct illustration of convergent evolution.
In life, if a person does not have a healthy relationship, then their emotional and mental health starts to deteriorate, thus affecting their happiness. This is the same concept that applies to the impala and the oxpecker when the oxpecker tries to be helpful by eating the ticks. However, sometimes the oxpecker goes back on its word and commits an action that hurts the impala, like feeding on an open wound instead. This can lead to infections, and while this type of action is very low, the frequency of wound feeding events on wild host species was only 3.1% of feeding events, according to Al Comrink, which still has an impact on the lifespan. The behavior of the oxpecker depends on the density of the ticks and its mood based on the weather of the environment. On a hot day where ticks are most likely to be present, the oxpecker are less likely to cheat on the impala. That is, the oxpecker's actions can decrease the lifespan of the impala. This sometimes leads the impala to dislike the mutualistic relationship, but it is of utmost importance to their stability so they continue with the relationship. Furthermore, one can expect oxpeckers to feed more on ticks than on wounds. In the first half of the 20th century, the oxpecker population decreased as a result of overhunting ungulate species and the pest epidemic. The ungulate species population decreased as well. So they adapted by making sure they maintained this mutualistic relationship with their host for survival. These findings suggest that a high abundance of the tick species and tick stages is necessary to maintain the alignment of interest between oxpeckers and ungulates. When ungulates host a few ticks of the oxpecker's preferred species, the birds will wound feed to meet their nutritional demands. Such wound feeding threatens the balance of the oxpecker-ungulate mutualism. Despite these setbacks, impalas have abilities to self-groom such that they are less dependent on oxpeckers and enabled to continue to coexist with the oxpecker in a way that the oxpecker is not detrimental to the impala. Tick-feeding bird decreases the host tick load, which in turn prevents blood loss, host anemia, host appetite suppression, the spread of pathogens, and tick reproduction, according to Little of 1963. This increases the fitness of the impala and the oxpeckers, so their marriage isn't so bad after all.